All right, let's take a look at this next question. It says, Lisa said that 6xy quantity squared is the same as 6x plus y quantity squared. Is she correct? Okay, now here's the deal. Before we talk about whether or not she's correct, and we don't know enough to do this problem yet, however, I want to show you we can kind of talk about it. For instance, we know this is these are terms, 2 terms, and these are 3 factors. But we could put in numbers. Let's say x equals 2 and y equals 3, okay? All right, if x equals 2 and y equals 3, and I could have used any numbers. I stay away from 0 or 1 because sometimes funky things happen there. Okay, 6 times 2 is 12 times 3 is 36. So that's 36 quantity squared. Now I could do that if I wanted to, but just come over here and see what's going on here. If I did the same thing, now if this and this are the same, that means my answer in the end has to come out to be the same. So let's take a look at that. This is 15 squared. 15 squared is definitely not going to be the same as 36 squared. So I have just proved that these are not the same. So I did not prove yet how to do them, but I proved they are not the same. So before I prove how to do them, okay, we're going to take a look at some other problems. Okay, here's the thing I want you to understand. That remember, all algebra is the general form of arithmetic. So whatever is true in algebra is true when we plug in those numbers, okay? So don't worry about that. So let's look at this next question on your slide, which is right up there, 5x, right in your workbook. 5x times the quantity of that big thing. We're going to deal with that, and then we can learn more. All right, so, oh, this looks ugly, doesn't it? Lots of letters going on. Let's look at the difference between this and this. I almost said side, but there are no sides here. So these here are attached by addition. So they're terms, 2 terms. These are all attached by multiplication. So to do this, I first have to try to do the parentheses. I look to see if I have like terms, and I do not. So now that means I have to distribute. Okay, so to distribute, 5 times 2 is 10. Keep the base, x, add the exponents. 5 times 3 is 15. Keep the base x, add the exponents. So that's what I have there. Now notice this. These are all factors. Remember, there is a rule. We talked about this a long time ago, and it's in your workbook somewhere, and it's coming up. But we have 3 factors. Actually, we have more than 3 factors. Okay, we have lots of factors on this side. Okay, the deal is we can multiply any 2 together, and then our answer by our next one. So here we go. 2x times x squared is negative 2x to the 3rd. And just in case you didn't see what just happened, all I did was add the exponents. Here, I keep this, nothing I can do. Not like terms. Now, a negative times a positive is a negative. There's really a 1 here you don't see. 2 times 1 is 2. X to the 3 plus 1 is 4. Y comes along for the ride. Okay? Now, once everything is attached by plus or minus, I get to combine if there are like terms. Well, here's an x fourth y, same as x fourth y. I can combine those 2. I have 10, but I owe you 2, so I have 8. Keep the like term, remember, plus 15x cubed. So it's all a matter of just extending the rules we already have learned, okay? So that's how you do that problem. All right, these almost look exactly the same, but right, this one has a set of parentheses that this does not have. So let's see how they're similar. They're similar because almost every number and letter looks the same. They're different because the parentheses are in a different place. Okay, or actually I should say maybe there's an extra set of parentheses here. Okay, let's talk about how we we're not solving anything, how we simplify these differently. Okay, here the only thing being multiplied by the 5x plus 1, and we know it's attached by multiplication because of the parentheses, is the negative 6. Okay, how do I know that? Because the 3x is attached to the 6 by a minus, so I know that's not getting multiplied. So here's how this looks. It looks like, since I can't combine here, I'm going to have to distribute this negative 6. So ready? All right. We get negative 6 times 5x is negative 30x. Negative 6 times a positive 1 is a negative 6. Now, once I'm all attached, once the parentheses are gone, and I'm all attached by plus or minus, I try to combine. Looking for like terms, I have them. So I have 3 x's, I owe you 30, so I owe you 27 x's minus 6. That is the answer to that question, and you are done. Okay, so that's pretty simple, pretty straightforward. Okay, let's see how this one is different. Well, this one is different because there's an extra set of parentheses here. So what is really being multiplied by the 5x plus 1? Well, if you think about it, it's this whole thing, okay, because the whole thing is in parentheses. Okay, so this whole thing is being multiplied by this whole thing. So here's what we're going to do. The easiest way to look at this probably is to forget about that negative 6 for a second and just, let's hope this doesn't fall off. 3x times 5x is 15x squared, because I multiplied the coefficients, keep the base, add the exponents. 3x times a positive 1 is a positive 3x. Now there's nothing else to distribute my 3x to, so now I'm done with the 3x. I cover that up, and I distribute the negative 6. Negative 6 times 5x is negative 30x. Negative 6 times a positive 1 is a negative 6. So that's how you do that. Now, once everything's attached by plus or minus, you combine like terms. So we have 15x squared. They have no friends, no other x squared terms. These two are like terms because they both share that x. So I have 3, but I owe you 30, so I owe you 27x's minus 6, because minus 6 has no friends. And that's it. That's your answer. So it's really very, very simple. I think now we're ready to hit that challenge problem. All right, now we can do it. We already said these were different. Now, before, I did not really even suggest this. I just gave you numbers. But also remember this. This is power to power. Factors raised to a power, power to power. We can't do power to power on this because it's terms, right? We talked about that earlier. So I'm going to do power to power here. Remember, I like to put little exponents if I don't see them. So, and I like to keep my numbers in parentheses. So that's 6. 1 times 2 is 2. X, 1 times 2 is 2. Y, 1 times 2 is 2, which is 36x squared, y squared. Done. That's the answer to that problem. Now we can do this one. 6x plus y quantity squared. I can't do power to power. I have to write that twice. But now we know how to do this. We just did a problem like this. So what we're going to do is we're going to distribute the 6x to everybody there. Okay, I'm going to close up this y. I'm going to distribute the 6x to everybody. Close up the y, and we're going to get 6x times 6x, or 36x squared. 6x times a positive y is a positive 6xy. I've distributed the 6x to everybody I can. Now I got to close him off. Oh, my y got messed up. Okay, no worries. Here we go. They're going to distribute the y. Positive times a positive is a positive 6xy. Positive times a positive is a positive. Y times y is y squared. That's it. Now once we have everything attached by plus and minus, we try to see if we have like terms. 36x squared has no friends. These are the same, like terms. So we have 12xy plus y squared. We are done. That's it. So I just want to say something to you. That's the way I do that. I distribute. All I did was distribute, 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 distribute 4 times. I have to be honest with you. When I was in 9th grade, they taught us something called FOIL to do this. And I'm dyslexic. I never did FOIL. I did FLIO. I did philo. I did probably everything but FOIL. Okay? So when I went to teach 9th graders the first year, like 100 years ago when I first started teaching, okay, here's what happened. I taught them this method. And I said, I don't know how to do FOIL, but I did this. And somebody in the back of the room raised their hand and said, hey, hey, hey. And I went one, he said, you just did FOIL. I go, I did? And they go, yeah, you did. I didn't even know I did FOIL. Let me explain FOIL to you. I'm going to put this back up. You don't have to do this. Just distribute. And the reason I like to just distribute is because distributing works for any type of problem. FOIL only works with a binomial times a binomial. But this is what FOIL says. Ready? FOIL says, okay, first, outer, inner, last. I think it was somebody's determination to make this simple. I think it made it hard because as a dyslexic, I didn't really know what was the outer and the inner terms. I know that's weird. But here's what FOIL stands for. Take the first term in every single binomial and multiply that out. So that's 6x times 6x. Then take your outer terms. Now this is where I goofed. This is where I never picked the right terms, because the outer terms to me was the out here. That's not the outer terms. The outer terms are the outer terms. So it's right here. So 6x times positive y. Then take the inner terms. The inner terms are those terms that almost touch. Terms that almost touch. So that positive, right here, positive 6x inner. Positive 6x times positive y. And finally, last is the last one in every spot, which is y times y, which is 36x squared plus 6xy plus 6xy plus y squared, which is exactly the way we just did this. We did FOIL. So all FOIL is distributing. And of course, you finish it up by collecting the like terms. So FOIL is this distributing back, distributing. So what is FOIL? It's distributing 4 times. That's what FOIL is. But if you ever hear it again, first, outer, inner, last. And I have to be honest, these outer and these inner terms are kind of important later. But that's what FOIL is. So the first terms are the first one in each box. The outer terms are the, and I'm going to get this wrong again, the outer terms are these two, outside. I have to think about it. See, I hate when I have to think about it. The inner terms are these, and the last term is the last one in each box. First, outer, inner, last. But personally, I like to distribute. Pick your own poison. All right? There are 4 problems on this next slide and in your workbook. Try those on all the different ways you understand how to multiply, and then click back when you're ready. Okay? This is either foiling or just distributing, which is really the same thing, but I don't have to go find my first, outer, inner, last terms. So here we go. 3x times 2x is 6x squared. Positive times a negative is a negative 3xy. Be sign conscious here, you'll lose some signs. A negative times a positive is a negative 2xy. A negative times a negative is a positive. Y times y is y squared. So I have 6x squared, combining like terms. I owe you 3xy's. I owe you 2xy's. They are like terms. So I owe you 5xy's. Plus y squared. Y squared has no friends. I am done. Awesome. Okay, let's talk about this. Sometimes I understand that every time we teach something new, people go crazy. We teach distributive property, people want to just distribute on everything. We teach you how to clear fractions, you want to clear fractions everywhere. You got to be careful. The only place you can clear fractions are in equations and inequalities, because you can keep everything in balance. This is just an expression. You cannot clear the fraction, which means you have to use the fraction. Now, you can change 1/2 to 0.5 if that makes you happy. But be careful, because you can't do that with a fraction like 1/3. Because you recall, 1/3 is 0.33333. You'll have to round it somewhere. It won't be exact. So I think you need to get really familiar with these fractions. So this one's easy, 1/2 of 6. Well, that's 3. Y to the first times y squared is y to the third. Minus. Now we're going to take 1/2 times a negative 3. So that's a negative, but this is all you're doing. It's just 3/2. So this is 3/2 y squared. A positive times a positive is a positive. So we did this, sorry. And now we're going to distribute this over here. 1/2 of 4 is positive 2y. You are done. No like terms. If you want to write this as 1/2, have a party. If you want to write that as 1.5, have a party. Doesn't matter. All the exact same thing. Doesn't matter. Okay, so we're done with number 2. Rolling along. All right, let's go to 3. Okay, now look. Beware. Ding, 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 ding. Beware. Here's the problem with this problem. I know that you all want to square each piece. That only works with factors. Power to power only works with factors. Jump up and down if you have to. Throw something. Only works it with factors. So here we go. We're going to have to write it twice. And yes, we have fractions to deal with. Oh, no. Cannot clear the fraction because it's an expression. Distribute the x. We get x squared. Positive times a negative is a negative 2/3 x. Negative times a positive is a negative. We get 2/3 x. Negative times a negative is a positive. Now, here's what we're doing. 2/3 times 2/3. Yes, that's 4/9. Not so bad, really, I swear. Okay, now we're looking for like terms. We have x squared. Now, these are like terms because, and they're easy to add. Not only are they like terms because they both have just x, but they're easy to add because they have the same denominator. So I owe you 2, I owe you 2, I owe you 4. Keep the denominator. So this is your answer. X squared minus 4/3 x plus 4/9. How cool is that? Okay, here we go. The only thing here being attached to this x plus 9 is the -8. So we're going to distribute that. So here we go. 7x. Negative 8x. Negative times a positive is a negative 72. 8 times 9. I have 7x's. I owe you 8. So I owe you 1x, or just x, minus 72. So negative x minus 72. That is a done deal. Okay, so let's see if we can extend what we've learned to this next problem. So this next problem says 3x minus 1, the quantity of 3x minus 1. Remember, the quantity of means the whole thing. The quantity of 3x minus 1 times the quantity of 6x squared minus 5x plus 1. Okay? This is the problem we're going to try to do. Now, you can't do FOIL on this. See? FOIL only works for two binomials. Okay? This is a binomial times a trinomial. What do you think, if you think about how can we extend what we know? Well, in FOIL, in multiplying binomials, when we weren't using FOIL, all we did was distribute. That's what we're going to do here. Okay, so let's multiply this using the distributive property. We have 18x cubed. A positive times a negative is a negative. 3x times negative 5x is negative 15x squared because we're adding the exponents. 3x, a positive times a positive is a positive. 3x times 1 is a positive 3x. Now, I have to tell you, now we're going to distribute the negative 1. This is up to you. This is just something you might want to do. This could get very long across the board. So what I tend to do is when I start distributing the next one, I put everything under their like terms. So negative 1 times 6x squared is negative 6x squared. Kind of makes it nice and neat. A negative times a negative is a positive 5x. A negative times a positive is a negative 1. The other thing I think about is exactly what's going on. I'm multiplying by a negative, so the only thing that's going to happen is I'm going to get these same numbers with different signs, because that's what negative 1 means, is it means the opposite of. So let's combine our like terms. 18x cubed minus 21x squared plus 8x minus 1. We are done. So if you just understand the distributive property, you can do so many other problems. Let's take a look at another problem that actually you have choices about on how you want to simplify it. All right, let's take a look at this. First question, how many factors make up the expression? The most common answer I'll get is 3. Is 3 the correct answer? Actually, the answer is 4, because 5 is a factor, a is a factor, 2a minus 1 is a factor, 7 is a factor. So there's actually 4 factors, okay? 5a is already multiplied together, okay? So here's what I want to do. I want to take a look at this in number 2, and I want to multiply it 3 different ways, okay? So in a, I want to multiply the 5a and the 2a minus 1 first, okay? So I'm going to so here's what I got. I got this, and I want to first multiply the 5a times the 2a minus 1. So I'd be doing this. 10a squared minus 5a. The problem with this technique is you have to be really careful, because remember, the rule of thumb is when you have more than one factor, multiply any 2 together, your answer by your third, and then your answer by your next one, and then your answer by your next one. So this is my answer that I multiply by my next one. If I did not use parentheses here, I would have gotten this wrong, because without the parentheses around this, then the only thing the 7 should have been multiplying would have been the negative 5a. So you have to remember, you have to multiply your answer by your next one. Now I could distribute the 7 and get 70a squared minus 35a. So that is the answer to that question. And that's by multiplying it first, the first 3 factors first. Okay? Here we go. The next method asks me to a times 2a minus 1 times the 27. Second thing asks me to multiply the 7 and the 2a minus 1 first. So it's asking me to do this. Again, I'm going to need parentheses because my answer's got to be, my whole answer's got to be multiplied by that. So it's asking me to do this. 14a minus 7. And then I'd have to go 5 times 14a is 70a squared minus 35a. That's the second way. Third way is asking me to multiply the 5a and the 7 first. That's 35a times 2a minus 1. And notice, once I do that, I already would leave that in parentheses because it's in parentheses. And I get 70a squared minus 35a when I distribute. Should I get the same answers? Absolutely. Why? We're doing the same problem 3 times. Now, you have to pick your own poison, but here's what I suggest. I like, when I have more than one factor, to multiply the things that look alike first. What do I mean by the things that look alike? I mean like in the type of polynomial this is. For instance, that's a monomial. Now, I know 5 and a are really separate factors, but you know, they're already together. So, but either way, that's a monomial, that's a binomial. So I would actually probably use method C, because I would have multiplied the 7 times the 5a first. I just think it's easier, but that's absolutely up to you. Would there have been another way to multiply this? Yes, you could have multiplied the 7 and the a first. Okay, so there are other ways to multiply this, but my point is that I would multiply the things that match in terms, in number of terms first, the expressions that match in number of terms first, but absolutely up to you, because you have to be careful that you have to multiply the answer by your next factor. So if you don't do that, you may sometimes have to put in your own parentheses. Okay, so let's look at a couple more problems. Okay, first thing I want you to remember is you can't do power to power, so you're going to have to write this binomial twice. Now, if I'm going to live with my rule of thumb, which was multiply the things that actually look alike first in number of terms, I'm going to multiply these two first, okay? Because these are 2 binomials, and that's a monomial. So I'm going to multiply this first. Put my answer in here. 5a cubed times 5a cubed is 25a to the 6th, because keep the base, add the exponents. Then a positive times a positive is a positive. 5a cubed times 1 is 5a cubed. Everything's positive, so I don't have to worry about it. Oh, I didn't make my parentheses long enough. Okay. And then positive 1 times 1 is 1. Then I distribute my a to the 4th. Remember, there's a 1 here, so none of these coefficients are going to change. And I'm just going to get 25a to the, add the exponents. A to the 10th, okay? It's getting a little crowded here. Plus 5a to the 7th. Oh, you know what? I actually goofed. Because you could do this, but you know what you should do first? What you really should do first is order of operations. Order of operations said, see, I'm going distributive happy. That's what I call distributive happy. What I should have did first was combined like terms. So sorry. That's why I have an eraser. Okay, these are like terms. I get 10a to the what? To the 3rd. You don't add the exponents unless you're multiplying. Plus 1. Okay, so this is what I have. The other way would have worked out, but I'm not following order of operations, and I really should. Okay, here we go. 25a to the 10th plus 10a to the 7th plus a to the 4th. There's no like terms. I am done. So that's that problem. It's up to you. I chose to multiply these two first. Did it matter? No. I just like that method. Okay, so in your workbook, there's 2 problems that say 2x minus 1, 2x plus 1. That's the first one you're multiplying together. And there's another one right next to it. Try those 2, and then we'll check our answers. All right, let's take a look at this. If you use the distributive property, or whatever you used, FOIL, whatever you use, you get 2x times 2x is 4x squared. 2x times a positive 1 is a positive 2x. Negative 2x minus 1. And we get, good night, 4x squared minus 1. That's our final answer. Okay? Awesome. Let's try this one. 5x squared times 5x squared is 25x to the 4th. Positive times a negative is a negative. 5x squared y. Positive times a positive, positive. 5x squared y. Positive times a negative is a negative. Y squared. Good night. And we get 25x to the fourth minus y squared. So the middle term are opposites in both these cases. Now listen, if you did FOIL, just so you know, if you did FOIL, this would have came from. If you did FOIL, not a big deal if you didn't, but if you did FOIL, this is where that would have came from. Now notice, in the OI terms, in both cases, the OI terms, which we call the middle terms, dropped out. Why did that happen? Well, it happened because your first term matched and your last term were opposites. Because when you multiplied in here, you were multiplying a negative 1 times a positive 2x, and here a positive 1 times a positive 2x. So the middle terms matched because of that fact. That will always happen. The middle term will always drop out if your first term matches and your last terms or your second terms are opposites. Okay, it will always happen. In fact, these are called conjugates. 2x minus 1 and 2x plus 1. It's on your slide. Conjugates. 2x minus 1 and 2x plus 1 are conjugates. Do not confuse conjugates with opposites. Okay, as you see on your slide or in your workbook, the 2x minus 1, its conjugate is 2x plus 1. 2x minus 1, the conjugate is 2x plus 1. First term matches, last term or second term are opposites. But the opposite of this, the opposite would be for every sign to be opposite. Negative 2x plus 1. Because remember, to make an opposite, you divide through by negative 1. Okay? So that's the difference between conjugates and opposites. Now let me explain why that's so cool. That tells me that if I see I have conjugates, I could just multiply as usual, I just did, or I no longer have to distribute all of this because I know this is going to knock out every time. The OI will go. Every time the OI will go. So if I have conjugates, if you see them, if you're positive they're conjugates, you don't have to distribute. You just have to flu. Just flu. What flu? Flu means multiply the first term by the first term and the last term by the last term. Let me give you an example of that. One example before I let you do some on your own. Okay, this is nowhere in your notebook or your workbook or on your slide. I just want to show you this. Okay, these are conjugates. First term matches, last term are opposites. Negative 4, positive 4. All you got to do is flu. Multiply the first times the first. 10x times 10x, 100x squared. Negative 4 times positive 4, negative 16. You are done. Can you FOIL? Yes. But what would happen to the middle term? It will drop out. So pick your poison, flu, or distribute. Doesn't matter. But remember, this method only works when these are conjugates. And it's really kind of important. And know what conjugates are. First term matches. Last terms are opposites, or second terms are opposites. So if you would try the next couple of problems in your workbook, and then we will check them. All right, here's the deal. Don't apply the procedure you learn, the 1 second you learn it, to everything that follows. You have to really be careful. Okay, I know I could distribute here 4 times, or I can notice that these are conjugates. If I notice these are conjugates, I could just flu. Okay, so here we go. Florida. All right, 7x times 7x is 49x squared. I'm going to multiply the first times the first and the last times the last. Negative times a positive, negative. 4 times 4 is 16. 5 times 5 is 25. I am done. That's it. So simple. Will you always get a negative here from conjugates? The answer should be yes, because you're multiplying opposites, negative and positive 4/5. Okay, couple things you need to understand here. First thing, no power to power in terms, so I have to write it twice. Are they conjugates? Nope, because the signs are the same. They're not conjugates. I'm going to have to distribute. 3y squared times 3y squared is 9y squared. positive times a negative is a negative. I'm multiplying 3 times 2/3. 3 times 2/3. Good night, that's 2. So that's 2y squared minus 2y squared. Negative times a negative, positive 4/9, because 2 times 2 is 4, 3 times 3 is 9. Good? All right, so don't go crazy with these fractions. Okay, I'm even making them easy. I'm trying to make them easy. All right, 9y squared. I owe you 2, I owe you 2, I owe you 4y squared. Oops. What did I do? This shouldn't be squared. That's all good. I got it. 3y squared times 3y squared is 9y to the 4th. Don't worry. This is why we have erases. 9y to the 4th. 9y to the 4th. All good. Plus 4/9. We're done deal. See, it's a good idea to be able to see that you made a mistake because they matched. That shouldn't have happened, so that's all good. I pretended to make an error. No, I really didn't, but I thought that would go over. Okay, let's take a look at number 3. These are conjugates. First term matches, last term are opposites, so we can just fool again. So we're multiplying 0.1 times 0.1, and we get 0.01. Okay, a positive times a negative is a negative. 3 times 3 is 9x squared. We're done. Conjugates. Conjugates. We're done. They're easy. I love them. Okay? And that's it with that problem. Let's see how we can take this and apply this to something in possibly real life. Okay, here comes my swimming pool. Uh-oh, you're in big trouble. You know that, right? You know that already, that you're in big trouble if I have to draw something. Here's my rectangle. Here's my water. Oh, look, it's blue. Perfect. Okay. I have blue water in my swimming pool. Okay, a rectangular swimming pool measures 30 feet by 10 feet. Okay, so this is 30 feet, and this is 10 feet. Okay, it's concrete. If a concrete walkway of uniform width x, what does that mean? Okay, here comes the walkway of uniform width. Now I have to tell you something. All right, I'm gonna fix this so that you can see it. Okay. That means, yeah. That looks like another rectangle. But that looks like it's the same on all sides. Uniform means the same on all sides. Uniform means the same on all sides. Uniform width. Okay, they're calling it x. Remember, this was 30 feet. I'm going to put the 30 in here and the 10 here. Okay, now here's the deal. We want to know what is the area, total area of the pool and the walkway. So we want the area of this whole thing. We want the area of the whole thing. The whole thing. So that means we need to know the length of this and the width of this. And once we have that, we can get the area of the whole thing. Okay, so watch this. Now watch. Here we go. This is 30 from here to here. Okay? So from here to here is 30. But this piece is x, and this piece is x. So if we're 30 from here to here, and this piece is x, and this piece is x, what's the length of that whole side? Well, that whole side is x plus x, or 2x plus 30. 2x plus 30. X plus x, 2x plus the whole 30. Okay? So that's the length of this side. If this is 10 coming up and down, and this is x, and this is x, so this is 10 from here to here, this is 10, and this is x, and this is x, because remember it's x here and x here, then what's the length of that whole side? Well, it's 2x plus 10. So this is 2x plus 10. Of course, this is 2x plus 10. I'll just use that 10. So I know I have a rectangle. This is what I have. I have a rectangle that's 2x plus 30 by 2x plus 10, and I want the area. Well, how do I get the area? I multiply the length times the width. So all I have to do is 2x plus 30 times 2x plus 10. I cannot fool because I do not have conjugates, so I must distribute. So that's 4x squared plus 20x plus 60x plus 300. Like terms, 4x squared plus 80x plus 300. Do we have any, welcome to the feet? Yes. And this is all, this is area, so this is square feet. And the whole thing is the area, so it's square feet. And that's the area of the whole thing, the pool plus the walkway. And that is done, which brings us to the end of multiplying polynomials. What do you think we do next? We know how to add them, we know how to divide, we know how to add them, we know how to subtract them, we know how to multiply them. Think about what might be coming next.